When working with the real numbers, when we have expressions such as the square root of negative 25 or the square root of negative 49, our simplification of this would be that these numbers are not real. But there is a set of numbers that is a set that the real numbers are a subset of, where we can actually continue on in a simplification process, give a notation for it, and then also work with this new set of numbers. And this set of numbers is called the complex numbers. The complex numbers is defined to be the set of all numbers that can be written in the form a plus bi, where a and b are real, and I is equal to the square root of negative 1. Now, all of our real numbers are actually also complex numbers, because any real number I have, I can write it as the real number plus 0i, and it would be a representation that then shows that it is also within this complex number set. But there are a lot of other numbers that we haven't been able to deal with when just working with the real numbers, all the numbers that live along the real number line, that now we will be able to have a representation with in the complex numbers, and continue on to learn how to show that they're equal, how to add them, subtract them, multiply them, divide them, and also find their absolute value. So let's see what happens if we are working with the complex numbers. In the complex numbers, this square root of negative 25 we can rewrite as the square root of 25 times negative 1. And if we further simplify this, we can rewrite it as the square root of 25 times the square root of negative 1. The square root of 25 is 5. We can do that value. And then the square root of negative 1, that was the representation that we were going to use the I for. So this would be simplified as 5i. Now we normally write that, but if it says to write your answer in a plus bi form, we want it as a number without an I factor after it, plus the coefficient in front of the I. So here with our 5i, we have our coefficient in front of our I, so we could write this as 0 plus 5i. It's a number that we can write in a plus bi form, and where our a and b are real, and our I is equal to the square root of negative 1. So that is a complex number. Square root of 49, similarly, we can write it as the square root of 49 times negative 1. So the square root of negative 49 we write as the square root of 49 times negative 1, which is the square root of 49 times the square root of negative 1. Square root of 49 is 7, and the square root of negative 1 is I. So it simplifies to 7i. We could also write that in a plus bi form as 0 plus 7i. So now with this set, we can simplify those values that we have.